2, 3.
What's up, team? Today we're talking trapezoids. Trapezoids are quadrilateral with exactly one pair of parallel sides. I have two examples here. Trapezoid A, B, C, D has side A, B, and C, D that are both parallel to one another. Therefore, it's a trapezoid. Notice how B, C, and AD not parallel. Over here, EF, GH is our trapezoid. EF is parallel to GH, whereas FG and EH are not parallel. This one's a little bit more clear. Let's define a few things. We have bases, we have legs, and we have base angles. I want to talk through all of that. So trapezoid ABCD, the bases are going to be the parallel sides. So in this case, it's going to be side AB, that's a base, and CD is the second base. Those are just the two parallel sides. Now the legs, well, those are the other sides, the ones that aren't parallel. So in this case, it's going to be BC, and it's going to be AD. BC, AD, we call those legs when we're working at trapezoids. Base angles. We've worked with base angles with isosceles triangles in the past. This is similar but also different. Each trapezoid has two distinct sets of base angles. So those are just going to be the angles kind of on the side of the bases. So in this case, the first pair of base angles is going to be angle A and angle B. These are base angles in relation to one another. So we're going to say angle A and angle B. That's one pair of base angles. The second pair of base angles, they're distinct from the first pair, is going to be this pair, angle C and angle D. Because CD is the second base, so angle C and angle D in relation to one another are base angles. So angle C and angle D. Okay, same thing with the second one. It's the same process. I'm going to move a little quicker. EF, GH are the bases. EF and GH. I probably should throw these lines on top. The legs. FG and EH and EH. Same thing over here. They should all have the lines on top unless you're talking about the length. Base angles. Angle E and angle F are the first pair. Angle E and angle F. Second pair, angle G and angle H. Angle G and angle H. This is the word and. Sorry if that's messy. Okay, let's talk about a few distinct things with trapezoids and we'll wrap this thing up. First, trapezoid median theorem. So we've worked with medians before when talking about triangles. The trapezoid median theorem says if you find the median of a trapezoid, pause right there, let's find that median. That's if you find the midpoint of our two legs. So the midpoint is roughly here, the midpoint between these two is roughly here, and you go on and you connect them. There's a few things that end up being true. The first thing by definition, we're bisecting this segment FG and we're bisecting this segment EH. So we could say FG, the length of FG is equal to the length, oh boy, I need to throw some other letters in here. GH, I, and J. So we're going to say FI and GI are equal lengths. FI has the same length as GI. Additionally, we can say that EJ has the same length as HJ. Cool. Another thing we can say is we already know the bases are parallel. That's the definition of a trapezoid. The median is going to be parallel to that as well. So base FE, that's the one on top, is parallel to GH. That's the base on the bottom. That's not news. The news here is that IJ is parallel to those as well. They're never going to intersect each other, even if you extend them in both directions, all three lines in every direction, or both directions. They're going to be parallel to one another. Okay. The last thing about this that you'll need to know to solve some of these problems is to find the length of IJ. It's just going to be the average of FE and GH. So algebraically, if you want to find IJ, you could add the other two bases together, EF plus GH, and divide by 2. So say that FE we know has a length of 5, and say that GH has a length of 9. Well, if we wanted to find the length of ij, we'd add those two together. 5 plus 9, that's 14. Half of that is 7, so the length of ij in this case would be 7. So that's how to use the the trapezoid median theorem. This is the big takeaway. This is definitional stuff, so this is the big deal here, the big shortcut. Okay, last one. An isosceles trapezoid. ABCD, I tried to make it so it's isosceles. We remember with isosceles triangles that two legs had to be congruent to one another. That's the same thing with isosceles trapezoids. Two legs need to be congruent to one another. The big thing with isosceles trapezoids, not only that two legs are congruent, but both pairs of base angles are congruent as well. So we could say that angle A is congruent to angle B. Additionally, we can say that angle C is congruent to angle D. So again, base angles AB are congruent to one another, A and B, and then C and D are congruent to one another. Don't get this twisted though. Angle B and angle C, those are not congruent. Those aren't the same pair of base angles. Yeah, they're along the same leg, but they're not along the same base. So we have to be careful which ones we define our base angles. Okay, here's trapezoids in a nutshell. Let's dive into the practice problems. Let me know if you have questions. You got this.